please put your hands together. He's going to talk about treating objects like people, Matt Wynne.
So I've been programming for a living for about 15 years now, and I think most of that time I've been using object-oriented languages, and I thought I was doing object-oriented programming, but I fundamentally misunderstood something about how to think about objects. And I expect that most of you have too. And in the last couple of years, I've come to a new understanding. So this talks about how that misunderstanding came about, how my thinking's changed, and how that's changed my approach to designing Ruby programs. There's no C code. And I will present this as a battle between good and evil. So let's start with Cucumber. That's how I got drawn into Ruby, not through Rails actually. But I was drawn into Ruby because of this community of people who were trying to create tests that would speak to their users, the non-technical people on the team, so we could create closer links between programmers and non-programmers. And I got drawn into the Cucumber community. 2008, Aslak Hellesoy, on a beach in Norway, creates Cucumber from the RSpec story runner using Treetop. Anybody remember that as the parser? So let's go forward to the end of 2012, and we've now got a version of Cucumber that runs on Ruby, JavaScript, the JVM, and for .NET. Those parsers are all being generated by Ragel now. We're not using Treetop anymore. And there's 2 books about Cucumber. It's a really big deal. I think the Ruby community should be really proud of Cucumber. It came out of the Ruby community, but it's really used very broadly across lots of different kinds of organizations and lots of different platforms. But the original granddaddy of all of them, the Ruby Cucumber, is a bit poorly, let's say. Some people have even predicted its death. So how did this happen? The code is hard to maintain. It's really, there's a lot of problems in the code. There's a lot of difficulty. It's old code. So how's this happened? Well, for one thing, we all got busy. We grew up. I had a couple of kids, and I don't know how anybody else who's got young kids has experienced their effect on your open source contributions, but yeah. For me, it suddenly became a difficult thing to find as much time to work on Cucumber as I had, and the same happened with Aslak as well. And Aslak was working very hard on the Java version of Cucumber, so Ruby Cucumber kind of became my baby. Around the same time, we also bought a house, a beautiful house, but it needed quite a bit of work. So I had a few distractions. Anyway, those are my excuses, but getting back to the technical stuff, who here doesn't know how Cucumber, doesn't really have much of an idea about how it works? Wow, okay, not that many people. So I can skim this fairly quickly. Just to give you an idea of how you express a test in Cucumber, we have this idea of a feature, which is really just like a chapter in a specification document. And then there are these scenarios. So those are your test cases. And then within a scenario, there are steps which Cucumber runs through and it executes them. And if any of them fail, the scenario fails. So naturally, we built a domain model for Cucumber, which looks a bit like this. We have a feature, and the feature has many scenarios, and the scenario has many steps, right? And then we want to run it, so we get this thing called a formatter, which is going to print out the output. And we pass that in. So this is what we call an abstract syntax tree. There's one of those for Ruby as well. But this is the abstract syntax tree for Gherkin, which is the language that you write your scenarios in. And that's a model of the language that you've expressed your test in. And we pass the formatter into the AST, and it throws it around and sends out events to describe your scenarios and whether they're passing or failing, and the formatter prints out your output. So if you look at that as a sequence, it looks like this. So who here knows what the visitor pattern is? Design pattern. A few people. OK, so this is the visitor pattern in action. So the formatter is the visitor. So we pass the visitor into the root of the tree, say, will you accept me? And this means that the formatter doesn't really need to know the structure of the syntax tree, because the syntax tree is going to pass the visitor around inside itself. So first thing we need to know is, right, we've got a feature. So it says, right, before feature, we're about to execute this feature. Then the feature says, OK, I've got some scenarios. So it throws the visitor, the formatter, into the first scenario. It says, can you accept this formatter? So now the scenario says to the visitor, hey, I'm about to run a scenario now, so you can print out scenario, whatever my name is. Then the same thing happens with the step, and we fire a before step message back to the formatter, then we execute the step, and we store the state of the result of the step on the step object, right? Nice domain model, keeping all the data and the behavior all together. Fire out the after step event to tell the formatter what happened, what the result was. And then the scenario can work out, because if it's seen all these steps running, it can work out what its result was, tells the formatter about that. And then finally, we close the feature off. And that happens for all the scenarios. So that's how it works. It's quite complicated. There's a lot of messages flying back and forth. But it's kind of OK. But the thing is, Gherkin, the language that we express these scenarios in, isn't quite as simple as the first example. So if you notice here, there are two steps at the beginning of these scenarios that are actually identical. So Gherkin allows us, I don't know whose idea that was way back, to factor these out into a background. So logically, that's the same. Cucumber's still going to make two scenarios, each of which has got 3 steps, but you have expressed it in a slightly more readable way. So now we have a model of the data of the abstract syntax tree that looks like this. We've got a feature with many scenarios and many steps, and we may also have a background which also has many steps. Right? So there's one more feature of Gherkin, which is the scenario outline. That was actually my idea a long time ago. I'm not really sure in retrospect whether it was a good idea, but anyway, we live with it. And the scenario outline lets you express several scenarios using a kind of a template. So each of those rows in the table at the bottom is going to generate a scenario by substituting the values into the template in the outline. So now the model for the abstract syntax tree gets even more complicated. And this is actually the thing that the visitor, the formatter, is going to have to get bounced around to execute the tests. And if you can imagine a feature file that has a single background which gets visited once for the first scenario, and then we run another scenario and we have to go back into the background again, but we've already run it, it starts to get pretty gnarly. So there's actually the accept method on background as it stands in the master branch right now. And you can see why people have started to become a bit reluctant to maintain this code. So what did we do wrong? Where did we go wrong? Well, I think our first mistake was that we designed our domain model around the data. Where did I get this idea that this was a bad idea? Well, a couple of years ago, I read this book. Anybody read this book? Few people. One thing is it's Microsoft Press, right? So why would you touch it? That's what I thought for ages. It's probably just going to be some brainwashing device to get you to buy something. Actually, it's a deep book. He talks a lot about the philosophy of object-oriented programming. He's a Smalltalk developer originally, and it's a really deep book, really interesting book. And one of the key ideas I took from this book is that there are two major domains that we're operating in when we're making computer programs. There's the place where our users and our customers live, and then there's the place where we have to operate to build our programs with the stuff you've just been learning about in the last two talks, all this technical stuff with heaps and stacks and memory. The kind of necessary evil that we have to use in order to solve the problem. But what we're really trying to do is to solve a problem. And David West's philosophy about object-oriented programming could be summarized like this. If you can model the problem well enough, the solution will take care of itself. That's the essence of object-oriented design. So this book also talks about the roots of object-oriented programming. The first object-oriented programming came out in 1967. Anybody know the name? Similar, yeah. So these two guys, I'll have to look at my notes to remember their names, Kristen Nygaard and Ole Johan Dahl. So this language, similar to 67, it had classes, it had objects, it had subclasses, it had garbage collection. I wonder if they were using Mark and Sweet. But really interestingly, Similar was not regarded by the designers as a programming language. What they were trying to do was to simulate complex processes within factories and oil rigs and such like. And they wanted to try and model those processes. So they designed this way of expressing that model and describing it to a computer so that they could run simulations. And their philosophy here was that they should try to make it easy to create those models, never mind if that created more work for the computer. So I characterize Similar as on the good side. Let's go forwards into the 1970s. So the next generation of languages that came along after Similar happened around almost exactly the same time, the late 70s and the early 80s. And in 79, this guy, Bjarne Sostrup, was writing C code, but he really liked Similar. He liked the way that Similar helped him to structure his programs, and he wanted to be able to use these things called classes in his C code. He wanted to be able to organize his C code into classes because he thought it would help him keep his C code tidier. But there was some stuff that really pissed him off about Similar. Like this, it was slow, you know, the garbage collection didn't work very well. And it had some of this stuff like dynamic variable allocation or dynamic objects or something, dynamic typing, I think maybe, which just made the performance of the language really bad. And he just thought, if we could just cut out some of these features, some of these wishy-washy features, we could make a really fast language. That was his philosophy. At the same time, these three people, Adele Goldberg, Alan Kay, Dan Ingalls, created this language called Smalltalk. And here's Alan Kay. There's loads of quotes from Alan Kay, wonderful quotes about Smalltalk. But this one, like, why did he call it Smalltalk? He called it Smalltalk because he wanted the communication between the programmer and the computer to just be a matter of almost, you just had to kind of mumble your program, mumble your desires to the computer, and it would understand. So it was child's play, so a child could program in Smalltalk. So we have this kind of fork that happens in the object-oriented programming community around the end of the 70s. And Smalltalk is really, you can see, is a very kind of natural successor to similar, but C++ is really sort of moving out and much more concerned with the solution domain. It's much more concerned with making a fast program rather than making a program that can model the real world. Making a program that's easy to organize your code. So we've got two philosophies. And David West, in his book, talks about Western culture's sort of obsession with rationality and science, and how we're very attracted to kind of keeping things organized and structured. And so these two cultures kind of grew up around these two different programming languages. So on the one hand, you've got C++, and around that community you get books like Ed Jordan's Modern Structured Analysis, which talks all about data modeling. On the other hand, out of the Smalltalk community comes extreme programming. Anyone here doing XP at work? Domain-driven design. Rebecca Worth-Brooks' book all about responsibility-driven design. And then on the C++ community, we've got the UML, which is designed by this huge corporate giant to provide the one true process for creating computer programs. And as a side effect, it helped them to sell their products called Rational Rows. Anybody had the misfortune to have to use Rational Rows at work? Remember those days? Yeah, me too. So we've got two different cultures. There's a culture that likes structure and organization, and there's a culture that's a bit more free. And it was really wonderful to hear Matt's words this morning talking about this, about how the language that you choose sort of affects the way you think. So different people with different philosophies are going to be attracted to these different languages. So we could I can characterize what I'd consider good and bad object-oriented programming in these two ways. So on the one hand, we've got this culture of flexibility, collaboration, fun, maybe a bit of chaos. Maybe we accept that the world is a bit messy. And on the other hand, there's this sort of stuffy, tweedy culture of formality, hierarchy, centralized control. Good OOP is absorbed in the problem, where bad OOP might be a bit distracted by the solution. And there's a focus on messages, the protocols about how these objects communicate with one another, where the other camp would be more thinking about how to organize the data, how to model the data. And the good camp would be thinking about the behavior and the responsibilities of these objects. So the title of this talk is Treating Objects Like People. And that's one of the metaphors that David West uses in that book, is to think about when you're designing an object-oriented program, imagine those objects are people interacting with each other. What would they need to know in order to do that job? That's the data that they need to hold. But what responsibilities would you want to allocate to different people? And how do they need to communicate with each other about those responsibilities? So it's a really nice way to think about your objects versus trying to dissect your domain around the structure and the layers. Talking of layers, for years I always thought about layers in a software program as being flat, layered on top of each other. That's all the diagrams you ever see of layers. And I actually think we should be thinking about layers in object-oriented programs much more like this tree grain, where when we add layers, what we're doing is we're wrapping smaller objects that do special jobs with a bigger, more abstract object that does the thing that we need it to do, that coordinates those objects and buries them away so we don't need to worry about the details of how they're working. So, back to Cucumber. What we're going to do about all these problems. Well, for the last, 3-4 months, I've been working mostly with Steve Tuck on a rewrite of the internal bit of Cucumber that builds that AST and runs it. And the first thing that we fixed, so it was a ground-up rewrite. The first thing that we changed was we designed it around a responsibility-centric model. So now, instead of thinking about the data, we're thinking about what are the actors that need to work on that data. So we start with a parser that reads your raw Gherkin file in, and we compile it. But the parser builds the AST, that big thing with all the scenario outlines and backgrounds dangling off it. And then the compiler compiles that down into a set of test case objects. So we're modeling the problem domain more accurately now, because that's actually what you're trying to create when you're writing your Gherkin is a bunch of tests. And then that's what we pass to the runner. And then finally, the runner sends out messages to the report. So now, I'll show you the way that plays out in a minute. As we were building this new code base, there was a design principle which we tried to apply, and we successfully applied, I think. And it's been a revelation for me. So, you know, tell, don't ask? Yeah, most people know tell, don't ask. Well, have you tried to apply it in practice and found it was a bit of a pain? Yeah, me too. So there's a nice sort of embellishment on that, which I got from Growing Object-Oriented Software Guided by Test, the GU's book. And in there they talk about, so it's a bit confusing, I guess, the terminology based on the talk you've just heard, but they talk about 2 types of objects that are living in your program at runtime. They just put them into 2 buckets. There are objects, and objects have state and make decisions. And then there are values, and values are immutable. They are your data. Now, obviously, we have native values like floats and integers, but there's no reason why you can't create your own rich, interesting value objects for your domain. And that's exactly what we did with the version 2 of Cucumber. So the abstract syntax tree with the features and scenarios and scenario outlines and backgrounds, all of those are value objects. They're immutable. We don't let them execute themselves and remember their own results anymore. They're just data that represents that stuff that you've put in your Gherkin document. And it's the things like the parser and the compiler and the runner that are the objects that take that data and decide what to do with it. So Goose says, tell objects, but ask values. So it's okay to ask, it's okay to make a query, as long as the query you're making is on an immutable value object. And it's a really, really nice principle to apply. So here's what we've ended up with. Now when the parser runs through your Gherkin document, it's firing out these messages, so it fires out feature, scenario, step, and it fires those out of the compiler. Those little AST objects are firing out. And the compiler just bundles those up into test case objects. So now every point in the chain from this point on only needs to worry about a very simple protocol. Here's a test case. Here's another test case. So this is a simplified version, obviously. Between the compiler and the runner, we can introduce filters, which check whether the test case matches the tags that you've asked to run, or the line number, the specific features, the specific scenarios you've said you want to run, and we throw those away and don't pass them on to the runner. And it's very easy to plug more objects into this chain. And notice that there aren't any messages going back. So these messages are all just going forward all the time. So we don't actually need to remember any state. We just wire these objects up together, push the features through. And in fact, as soon as that last step of that first scenario is passed into the compiler, the test case fires to the runner, and the runner can start to execute that step immediately. So we don't even need to wait until the parser's finished parsing the whole feature file. It's already off and running. So when a runner takes the test case, it fires out before test case, before test step, runs the step, holds a result, and then fires out more messages. And again, it's not holding any state anywhere. So you could think about this, like this might sound a bit like a functional program, right? There's no state getting held in any of these objects. We're just firing out events across the set of objects. But actually, we don't need to. We don't need to hold any state anywhere. And that's really been an amazing thing about working with values so much and only passing those values out through tells to other objects, as you realize how little state you really need to hang on to. And that's made the code a huge amount simpler. I haven't counted, I would have liked to have counted for this talk, but the number of conditionals, the number of if statements in the new code base to run the same behavior, it must be a tiny fraction. There's hardly any. So less state, less bugs. My take on this, really, reflecting on it, is that having state lying around in your program is pretty risky. You know, the little dogs that Matt was talking about, you create these adorable little creatures when you write your programs, but they're not really that clever. And the more state you leave lying around, the more chance there is that the program is going to do something stupid with it at some point. And that doesn't mean that you're abandoning the OO paradigm and starting to try and write closure in your Ruby programs. There's plenty of state being held in the runner briefly whilst it executes a test case, but as soon as it's finished executing that test case, it throws the state away because it doesn't need it anymore. So I'm going to sum up. Tell objects, ask values. Remember that. Try it out. Make your data immutable. Making value objects immutable is a really, really powerful idea. And try and make your domain model the activity that's going on rather than the data. Put the data in the background and think about the activity instead, and just push the data through that model. And think about those objects that are doing that activity like people. How would they need to relate to each other? How would they communicate with each other? So I've been talking about Cucumber. I've got one more. This is a world-exclusive announcement that the three of us who work hardest on Cucumber these days, so that's Aslak, myself, and Julian Biesman, who makes the JavaScript version of Cucumber, we created a company about 2 weeks ago to give us a platform to try to see if we can make a living from this. So I've been making a living, actually, from the last couple of years from training people and teaching people about how to use Cucumber. And this is our product, which is going to be ready in the next couple of months to allow you to collaborate with your stakeholders around Cucumber features. So if you're excited about that, that's the URL. Please sign up and let me know what you think. And that's the end of my talk. Thank you.
Hi, it's a bit of a controversial one, so may delay lunch a bit. But the way you're saying you rewrite and everything, have you ever used Erlang? Because that's basically the way you write stuff in Erlang.
So no, I haven't used it, but I've seen it. And Steve Freeman, who wrote Goose, and he's a massive inspiration for me about the way I design object-oriented programs and the way I think about them. He says that Erlang's process is effectively the same as an object, the way that a small talker would think about an object. So yeah, and it's tell, don't ask manifest in a language, right? Because you can only tell other Erlang processes. You can't ask them things.
Yeah, exactly.
And you pass data around, so yeah.
As Matt was saying, like, the program does affect the program in the way you're thinking.
Yeah.
In Erlang, yeah, you'd have no state at all. It's like completely immutable. So.
Yeah. So it's limiting you, but I think that it's we're confusing ourselves to think that we've got functional languages over here and we've got object-oriented languages over here. I actually think there isn't that much difference if you're using them perhaps the way they're intended to be used, or in a non-imperative style, right? Because you can't write an imperative Erlang program. You can write an imperative Ruby program, but if you're going to write a big maintainable Ruby program, perhaps you should avoid writing imperative code in Ruby.
What technology stack do you use for Cucumber Pro?
Sorry?
What technology stack do you use for Cucumber Pro?
Who's asking the question? I can't see. That's weird. Hi. JavaScript. Yeah, it runs on Node. Yeah.
So, hi. Did you try looking at this through a CRC cards perspective, like class responsibility collaborators? Because it looks sort of like it. Did it influence you in any way?
Yeah. So CRC cards didn't get a proper mention in the cultures slide. That's one of West's points in that book is, on the one hand, you've got CRC cards, which are very kind of scrappy, loose, lightweight way of designing. And on the other hand, you've got UML. So Kent Beck and Ward Cunningham, who are the fathers of XP, came up with CRC cards. And CRC cards are a tool I use a lot to help me to get back into that thinking about responsibilities and interactions rather than thinking about data. I can't remember, to be honest, at what point I would have sketched out the CRC cards for the new Cucumber, but I must have done it at least once. Yeah, I've been thinking about it a long time. So. But thanks for reminding me about them. Who here has used CRC cards at work? Hey? Would like to. Right, well, try them out. They're very simple. He actually talks in that book about object cubes. So he has this idea of like getting, how many would it be? 6 index cards and sticky taping them together. And there are different things. So you don't just write in the front and the back, but you put like, I can't remember what you put on the sides and on the top. But I think CRC cards are enough.
I'm sure a number of people, the ideas of immutability and telling objects and asking values is new to them. Have you got any good pointers on resources that people could look up and find out more about how to write programs in this style?
Goose. I wish somebody would port Goose to Ruby, because I don't like recommending it to Ruby people because it's quite hard to read if you can't read Java. Sandy's book, yes. Yeah. I don't know if you particularly talk about immutability, no. But definitely the principle of focusing on message passing is very strong in that book. So it comes from the same philosophy. Are you a former small talker as well? Am I right in thinking, yeah, see? So I think the other thing I'd suggest is, as a reference, is github.com/cucumber/cucumber Ruby core, which is the new core of Cucumber. So we're gradually, right now, we're integrating that as the heart of Cucumber. We're kind of ripping out the middle of the main Cucumber. So that code base there is, I think, it's the best code I've ever written. And it applies that pattern a lot. So that's a good reference. And more people working on it and helping us with it would be wonderful. So check that code out. Have you got any suggestions, Chris? Whose? What? Which one? Objects on Rails, right? Yep. Anyone else got suggestions for good books that are from the good side of OO?
Since this changed the whole way you wrote the code for Cucumber, and you said it changed the way you think about object-oriented programming and so on. Did it also change the way you write your tests, like your Cucumber code? So, like, did it change the way you write your scenarios?
No, not really.
Like thinking about
What are
testing
you getting
values
at?
versus testing objects. Maybe testing values is different from testing objects. Something like
No.
I've got a
I
question.
don't know.
Wait.
So I suppose the thing to get out there, so maybe not think about Cucumber testing, but thinking about, so like there's a talk on a similar subject, Gary Bernhardt's talk about boundaries, and he's got a sort of different take on this, but he talks about the problem of mocking, and like lots of people really hate mocking because they've had a bad experience with it. Well, Stephen Nat, who wrote the Goose book, invented mocking, so they should know how it works. And their point of view, so they have this simple decision between, are you talking about an object or an immutable value? And what you mock are the interactions between the objects. So the objects are telling each other stuff and sending each other messages. That's what you mock. But values, it's fine to just, you should not mock values. So that's quite a clear principle, and when you sort of start to see that distinction, I think that can help with a lot of the problems that people have around mocking.
I suppose your scenario outline is good for testing values in a way, since you don't have to write these imperative steps. You can just write a table of values.
Yeah, I said I slightly regret coming up with scenario outlines. I do think that usually, if you're using a scenario outline, you probably should just be writing some unit tests. If you've got that many permutations that you want a table to express them in, you probably should be pushing that down the testing pyramid down to unit tests. But sometimes it's helpful for, you know, getting trust with your stakeholders to have all those different test cases surfaced. So, you know, it's a facility that's there.
I've got a question. Did all the things you learnt affect how you write your JavaScript code?
So we're basically
No answers will be taken. No, carry on. Okay.
We're going through the same thing again with the JavaScript code because Aslak's writing it all at the moment. So 3 years later, we'll all have to tidy up the mess. He's not here at the moment, so that's
right.
not fair to bag on him, is it? Yeah.
So I can't see a flood of the beautiful orange men that are organising the conference, which means they're still outside organising our blissful lunches. So you still have permission to ask more questions. Or they're eating all our lunch. We good? Hey! Class dismissed. Please put your hands together.